Module 2, Footwear Sustainability. Unit 3, Materials and Technologies for Sustainability Footwear.
Lecture 3.1. Footwear Materials, Properties and Environmental Impact. This lesson is structured as following.
Parts of the shoe. Materials evolution. Natural materials. Synthetic materials. Thermoplastic. Thermoset.
Footwear structure, materials evolution.
Footwear can be described as the union of an upper part and a sole. This last part can be broken down into 3 additional layers.
Insole, in contact with the foot. Midsole and sole, in contact with the ground.
Each part must satisfy specific needs, so it must be made up of different materials. Obviously, both the needs and the materials to obtain them have been changing over time. The first footwear manufactured by humanity had easy availability as its main need, so the first materials used were vegetable fibers and animal skins. Additional requirements have been added, such as comfort, durability, good fit and quality, foot protection, and today, the main criteria for innovation are to look for footwear that respects the environment, either at the time of manufacture or at the end of its useful life, as light as possible, flexible and comfortable but durable, requiring little maintenance and making it waterproof. The search for all these properties has led to the use of up to 40 raw materials in the manufacture of a shoe: natural and synthetic leathers, polymers and composite materials, or textiles, depending on the type and the different parts of the shoe.
Natural materials.
Leather is especially suitable for the upper part of footwear. It adapts its shape to the foot permanently. It is relatively breathable, and it resists stress and abrasion, although it acquires a plastic behavior in the rain, modifying its size. Leather soles have additional problems. There may be flaws in the leather, it is difficult to dry, expensive, and it has little shock absorption. In addition, ecological problems derived from its manufacture, such as the influence of its production on climate change, and new social trends such as veganism, have reduced leather to approximately 4% of the total market, and is mainly used for dress shoes. Vegetable strips, such as esparto grass, flax or cotton used in the early stages of shoemaking due to their availability, have long lost importance compared to the technical properties of synthetic materials, but are regaining importance again due to the concept of sustainability.
Synthetic materials. Synthetic materials have become important in the footwear industry because they solve some of the problems derived from traditional materials such as leather, better impact resistance, low water absorption or lightness, among others.
In return, they have created new problems such as pollution. These synthetic materials can be classified as thermoplastic and thermoset elastomers. An important advantage of thermoplastic materials is that it is possible to recycle waste materials, which translates into a reduction of both costs and waste. The main thermoplastic materials are PVC, thermoplastic polyurethane, and thermoplastic rubbers based on styrene butadiene styrene block copolymers, SBS, while natural and synthetic rubbers are examples of elastomers.
Thermoplastic, PVC, thermoplastic rubbers, SBS, and polyurethanes, TPU.
PVC became popular as a sole material due to its low cost, ease of processing by slush and injection molding, and the ability to manufacture multicolored soles. It also has disadvantages, such as its high specific gravity, aging towards plasticized appearance and, above all, ecological problems associated with the monomer from which it is manufactured, vinyl chloride. This balance of properties makes PVC the most widely used thermoplastic in the manufacture of soles, both compact and expanded, representing 36% of the world's sole production. Thermoplastic polyurethanes, TPU, have excellent abrasion resistance, good cut and scratch resistance, high tensile strength, excellent flexing properties, resistance to seawater and microbial attack and good low-temperature performance. In addition, TPU parts do not splinter, transparent formulations can be made with glossy and matte areas molded together, they have excellent adhesion to other materials in a shoe, and can be manufactured in combination with other materials, such as pure, EVA or vinyl rubber, as pieces of different density or various colors. Its main disadvantages are its high density and high cost, and limited grip properties on most surfaces, due to its high hardness. Efforts have been made to avoid some of these problems, such as modifying hard segments to reduce hardness or the use of low-density blowing agents. SBS copolymers for shoe soles are available worldwide, have high fill tolerance, low cost, and good physical properties such as softness, flexibility, and strength, and better abrasion resistance than natural rubber, although worse resistance to wear. Fatigue than this. It currently represents approximately 15% of all soles produced.
Thermoset, natural rubber and synthetics rubbers.
Natural rubber can be used in the manufacture of both vulcanized and uncured soles. The outer rubber soles have interesting traction properties, some cushioning capacity, durability, excellent low-temperature behavior and full compatibility with midsoles made from the same material. Natural rubber has excellent stretchability and better slip, cut and puncture resistance than PVC. It has good resistance to acids, bases, alcohols, and dilute solutions of most water-soluble chemicals. On the other hand, this material also has drawbacks, such as weakness with respect to oil solvents, and in general its high density. To solve these problems, modifications such as blown gum or carbon rubber have been investigated, with their own new problems. Former decreases density but also durability, and carbon rubber is lighter and the most durable type of rubber, but limited in colors. Natural rubber has been mixed with other materials to improve specific properties, HSR, high styrene rubber, for high abrasion resistance, EVA for low density and greater flex resistance. Chloroprene, CR, or neoprene rubber is one of the most important specialized elastomers, due to its great resistance to a multitude of chemical products. It shows strong adhesion to many substrates and can be vulcanized. It also has better resistance to oxidation and heat exposure than natural rubber, but worse flexibility at low temperatures and resistance to punctures, abrasions and cuts. Polyolefin elastomers have properties similar to EVA, a polymer with which they directly compete, but they are truly thermoplastic and therefore can be injected into a full-size mold, although they can also be used as thermosets. Its main drawback is that they are difficult to bond to other materials.
Thermoset, EVA and polyurethane rubber.
Polyurethane soles can be produced as lightweight rubber with excellent properties, such as good flexibility and abrasion resistance, good cushioning properties, the ability to manufacture in different colors, allowing them to meet the demands of fashion and ease molding with other materials. However, they are difficult to manufacture, since two liquids are involved in the process. There are blowing options that reach densities as low as 0.3 grams per cubic centimeter. Although polyurethane rubber has been the material of choice for midsoles for many years, it has now been surpassed by copolymers of ethylene and vinyl acetate, EVA, due to its lower weight, even 0.18 grams per cubic centimeter, maintaining good cushioning properties. The sustainability of EVA can be improved by using EVA residues as a component in the production of natural rubber, styrene butadiene rubber, or acrylonitrile butadiene rubber-based compounds.